Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. Going to the next problem, box stacking. So there's a one problem we can see we can solve by using longest increasing subsequence. The concept of longest increasing subsequence, which I explained in my previous video lectures. If you are not watched that, please watch it first. Why? Because in this problem we'll use the concept of longest increasing subsequence. So if you come to know how we need to solve the problem with for longest increasing subsequence, then only you can easily understand this one. Of course, this is a box stacking problem. We'll see what is this problem statement. You are given a set of n types of rectangular 3D boxes. Okay, like this, the boxes are given initially, where the ith box has height, hi, wi, and depth. So height is there, width is there, okay, depth is there. Okay, instead of depth, if you are still something confused, you can take it as length, something like length and width, or length and breadth, like this you have, and also height. You want to create a stack of boxes which is tall as possible, but you can only stack a box on the top of another box. There is a condition that if the dimensions of the 2D base of the lower box are each strictly larger than the box 2D base of the higher box. It is saying simple like, so when you keep the box, this box on top of this, means the area, base area of this box, that bottom box will be greater than the top box, like this it has to be. So it should not go beyond that. Of course, you can rotate a box so that any side functions as it bakes, and it is also allowable to use the multiple instances. Let us take an example here. Let us suppose if I take 4, 6, 7. Okay, 4, 6, 7. So might be you can take this as the length, this as breadth, this as height, or you have another options also. How many options you will get for the box? For a box you have totally 6 faces, right? So you may have 6 options. Let us suppose I'll go with 4 as length and 6, 7. Then 4, 7, 6 I can write, and I'll take 7 as length, and I'll take 7, 6, 4 and 7, 4, 6. Okay, I have 2 more options. What are those 2? I'll start with 6, 6, 4, 7 and 6, 7, 4. So like this I have 1, 2, 3, 4, 5 and 6 options for each box I have. So here it is asking you can take any one of these options for the boxes, and such that you have to arrange them such that the area of the bottom box should be definitely greater than the top one, like which you are keeping one box on the other box, right? So when you keep one on the other, so bottom one always should be, the area should be greater than the top one. So like this. And not only that, one more constraint here it is allowed. Not only area, even you can see the length also. If I take this is the length, this is breadth, so that also to be greater. The one which is on the bottom will be greater. So this is breadth, this should be greater, and this also should be. Let us suppose if I take 2 areas, okay, A1, A2, and the length and breadth are L1 and B1, L2 and B2. Your constraints are like such that not only A1 is greater than A2, you have to check it out. L1 should be greater than L2 and B1 should be greater than B2. All these constraints must be satisfied. Let us suppose if I take 2 boxes where I have length and breadth like this, 7, 4 and 7 into 3. Length and breadth. Let us suppose what is the area here? 28. Here the area is 21. Can I keep the box 28 on the top of 21? Can I keep 21 on the top of 28? So let us suppose this area is 21, this is 28. Can I keep like this? No. Why? Because of course the area is greater, but length and breadth also should be greater. But here you can see breadth satisfying, but length equal, then you cannot keep. That also to be taken into consideration. If they are equal also not to be kept. So let us suppose if I take like this, if let us suppose this is something like 8 into 4, 32. So 32 is greater than 21. So 8 is greater than 7. 4 is greater than 3. Yes, acceptable. Then you can keep this box 21 on the top of this box, which is the area 32. So this is what all these constraints must be taken into consideration and we need to solve. So out of these 6 phases, so whenever we want to solve, out of these 6 phases we will take only 3 phases. That means 3 options or three instances of a box. Why? Because we want to generalize the problem where I'll take always length is greater than breadth. Always length is greater than breadth, then we'll get only 3 options. We'll see this one. Let us suppose if I take 4, 6, 7, you can see if this length, breadth and height. So 4 is less than 6, 4 is greater than 6, no, I cannot take. 4 is greater than 7, no, I cannot take. 7 is greater than 6, I'll take. 7 is greater than 4, I'll take. 6 is greater than 4, yes, I'll take. 6 is greater than 7, no. So like this, if you take even any instance, any sort of these boxes, you will get only 3 options if I generalize like this. So totally, if I consider this is our input, 4 boxes are given. Totally I'll get 4 into 3, and 3 for each box. Totally 12 instances I'll get. Okay, and here the constraint is also like for each box there is an infinite supply of each box. So even if it is infinite, so there should not repeat, right? So that's why. So there is a instances of 4 boxes here, and for each 3 instances, 4 into 3, totally you have instances as total 12 instances you will find. So now you have to get the answer. What is the answer? Here you have to get the maximum height. So how to solve this one, we'll see. Anyway, for this one the answer is 60. I'll let you know how this answer is 60 here. So here totally 4 boxes. So one box with 4, 6, 7 are dimensions, another with 1, 2, 3, like this it is given. So how it is 60 means, you can see. So following all are the rotations of the bricks in the decreasing order of base area. Actually here it is taken like this. This is length, this is breadth, this is height. So this is height. Yeah, now you can see for 10, 12 and 32 only 3 instances are taken. I told you, no, only 3 instances, not 6. So you can see length 32 is greater than 12, yes. 32 is greater than 10, yes. 12 is greater than 10, yes. And of course these 3 are taken in decreasing order of the area. 32 into 12 you can do, that is the area greater than this one, right? 32 into 10, 320, which is greater than this one, that is 12 into 10, which is 120. And after this you can see this one also the same, 7 into 6, 6 into 5, 7 into 4. So this is 42, this is 30, this is 28. Of course all are in decreasing order, you can see. And 6 and 4, if you take for 4, 5, 6, 6 and 4, 6 and 4, and 5 and 4, and 3 and 2, 3 and 1, and 1 and 2. So like this, first it has taken, anyway this is not the final answer, first it has taken all this in the areas in decreasing order. So like this it has taken everything. Here you can see, so this is 384, this is 320, this is 120, this is 42, this is 30, this is 28. So you can see here everything in decreasing order, I mean non-increasing order here. So in this we need to find it out what might be our solution, right? So anyway I told you, like, not only the area, so their length and breadth also should satisfy. Like let us consider 6 is there, you cannot keep this box on the top of this box. Or you can consider one more here, of course the area is greater, but here it is not satisfying this one. Of course breadth is satisfying, but length is not satisfying the constraint. So anyway, we how to solve we'll see. And before that, what is our answer for this? So this is our answer. So bottom one will be this one, 10, 12, 32. So next, this is, I told you, no, this is length, breadth and height. And 32 into 12, which is this box, has kept on the bottom. Next 10, 12, this box. And next 7, 6, 7, this box. Next 5, 6, I think this box. Yeah, and next 4, 5, this box, and then 2, 3 and 1, 2. Okay, like this. So the heights, if you consider 10 plus 32, which is 42 plus 4, 46, 50, 56, 57 and 3, 60. So answer will be 60. So now how to get this one? Okay, little bit tricky. Of course, we feel like, okay, this is like we need to find the area, then length and breadth. Okay, you have to consider, but little bit tricky, and we have to solve this one by the concept of longest increasing subsequence. So we'll see this one step by step. Anyway, instead of taking 4 boxes, I'll take any 2 boxes, and I'll show you the answer. Okay, so to avoid more sort of the options, I'll take, let us suppose 4, 5, 6 and 1, 2, 3. Let us suppose I'll take 4, 5, 6 and 1, 2, 3. So boxes I am taking here in terms of length, breadth, height only I am taking. So I'll take here as 4, 5, 6. I'll first write 4, 5, 6, and then I'll take 1, 2, 3. So I have to take only 3 instances. So what 3 instances are possible according to the length, breadth? 6, 5, okay, 6 is length, and I can write 6, 4, 5 I can write, and one more instance is 5, 4 and 6. Anyway, the last part is height. Height is not a matter here. Okay, 6 is greater than 5, yes. 6 is greater than 4, yes. 5 is greater than 4, yes. Okay, so like this. And 1, 2, 3, the options possible are 3, 2, 1, 3, 1, 2 and 2, 1, 3, right? So these possible options I'll write here. So 6, 5, of course I'll write according to the area of the base. So 6 into 5, 30, this is 24 less than, this is 20 again less than, this is 3 into 2, 6, 3 into 1, 3, 2 into 1, 2. So according to this order I'll write here 6, 4, 5 and then 5, 4, 6, then I'll write 3, 2, 1, 3, 1, 2 and 2, 1, 3. I'll write here like this, and here also I'll write the areas which are required compulsory. 6, 3, 2. Anyway, I have to store these values in an array, so that's why I'll take here as array starting with the indices 0, 1, 2, 3, 4, 5 like this. So here also I'll write, so where I have to store the values. So 2 arrays are possible, required. So one is to get the height, one is to how you are building. So 2 things are very most important. So here how we are building, I mean what is the possible height we'll get. This is a height array, and this is what is the building blocks. I'll take it as B. Which boxes you are taking, anyway we'll find finally from this one. So which box finding the boxes. Yeah, I'll start from the first. Okay, anyway I told you like each box I can keep, even any sort of the constraints are not satisfied, each individual box I can keep, I mean only one box I can keep, so that I'll get the maximum height. And remember this point, I am finding only the only for 2 boxes. I am not taking 4 boxes which is given in question. I am taking the answer for these 2 boxes only. What will be the maximum possible height for this one I am finding for this 2 only. So now each box I can keep individually so that I can get the height, right? So that I'll do here. If I keep like this, what will be my answer? So for each one, what is the height here? I'll write it first. So here for 0, first one, what is the height? 4. For 1 it is 5. For 2 it is 6. Next 1, 2, 3. So each box height I have taken initially. That means each individual box can be kept separately, so that might be the answer in worst case. Now the thing is, you have to check it out each one by one. Can I keep one box on the top of another? Like this we need to check it out. Now here the concept of longest increasing subsequence will come into picture. So where I am checking, either 0 box can be kept on, 1 box can be kept on the top of 0, 2 box can be kept on the top of 0 box or 1 box, 3rd box can be kept on the top of 0 box or 1 box or 2 box. So this is somewhat like going with the longest increasing subsequence, where I starts from 1 up till goes to the last, j starts from 0 up to I minus 1. So this is what the procedure will take, and we'll see this one by one, where I starts from 1. I told you j starts from initially 0 up to I minus 1 means initially only 0 I'll take. Yeah, I'll check it out first. So can I keep the box 1 on the top of box 0? So the first constraint is area has to be satisfied. 24 is less than 30, yes, fine, but length and breadth you can check it out. Is that 6 is less than 6? Not satisfied, so I cannot keep on the box 1 on the top of 0. Check it out. 6 is less than 6, no. Of course 4 is less than 5, that is satisfied. Length also to be satisfied, so I cannot keep. So that is over for I equals to 1. Now I will come here, the I value 2. So j again starts from 0 up to 2 minus 1 1. So now the box 2, so what is the value here? 5 4. So here 6 5. Anyway 20 is less than 30, we know, and 5 is less than 6, yes, true. 4 is less than 5, yes, true. Yes, both are satisfying. Now I can say yes, the box 2 can be kept on the top of box 0. So I can keep, so I'll check it out. What is on the box you are getting? 0th box. So what is the value here? 4. So 4 plus now what is the value you are getting here? 6. So 4 plus 6, which is 10. 4 plus 6, which is 10, comma, what is the value readily now? What is the maximum height you have? 6 only. So 10 comma 6, what is the maximum value? 10. So that can be updated. So once again, here what is the value, you have to check it out, and now what is the sum you are getting? That means you can keep on the top of 0. So what is the value here? You have height, so we are talking about height. 4 plus, now you are keeping 6. 4 plus 6 10, and already you have only one box, that is 6. So 4 plus 6 10, that you can keep, and come here immediately, and here also each box separately you are keeping. That's why these values are initially 0 to 5. Now here in the 2 you are keeping, which box you are keeping? 0th box. So here you have to, what is the top of the box will be? 0 on 2. So that's why you have to keep 0. That means I am keeping here on the box 2 on the top of 0. So box 2 on the top of 0. Now j value is 0 over j value is 1. Can I keep the box 1, box 2 on the top of 1? Can I keep? You can see 20 is less than 24, yes, fine. 5 is less than 6, yes, fine, but 4 is less than 4, not true, right? It is equal, it's not less than, so that's why you cannot keep box 1. So that's it over, and now I will come here, the value of I is equals to 3. So 2 is over, 3 is now, anyway j will again starts from 0. So can I keep the box 3 on the top of the box 0? You can check it out. 3 is less than 6, fine. 2 is less than 5, fine. Anyway area is also fine. So that's why I can keep the third box. So what is the height of the third box? 1. Now you can see 4 on box 0. 4 plus 1, which is 5. Already you have 1. So 5 comma 1. 5 comma 1, which is the maximum? 5. So you can get here as 5. And immediately here also you can update. You want to keep on the box, on the top of, below of the 3 you want to be 0. That means on the box 0 you are keeping 3 here. Now this is fine, j equals 0 is fine. Now j equals 1. Can I keep the box 3 on the top of 1? You can check it out. 3 is less than 6, yes, true. 2 is less than 4, yes, true. Now 6 is, of course, this is true. Now can I keep? Yes, I can keep the box 3 on the top of 1. So now you can see what is there in box 1. The height is 5. 5 plus, what is the value here? 1. This value, not this value you have to. 5 plus 1, which is 6. Now what is the value here? 5. So 6 comma, what is readily available? 5. Which is the maximum? 6. That is what. So 6 I updated. When I update, you have to update here also. On here instead of 0th box, what you need to keep? 1. Box number 1 you have to keep. That means 1, the top of 3 you are keeping box 1. Now the next one, j equals 1 is over. Can I keep box 2? That means here you can see, anyway 6 is less than 20, 3 is less than 5, yes, true. 2 is less than 4, again this is also true. So all 3 conditions are satisfied, yes, I can keep. So now you can see what is box 2, you have the value. So what is the value you have on box 2? You have 10, the value. Now 10 plus, what is the value? Right now you have 1. 10 plus 1, which is 11 comma, what is the value readily available now? 6. So 11 comma 6, the answer is 11 is the maximum. And here you can see what you want to keep on the box 3 below of the box 3 you want to keep here 2. So like this we need to update every time. So this is also fine, j equals to over, that's it. And now I value comes to 4. What about 4? I equals to 4. Anyway, j starts again with 4. I value is 4. J starts with 0. J starts with 0. And can I keep box 4 3 1 on top of 6 5? Yes, I can. 3 is less than 6. 1 is less than 5. Anyway, area 3 is less than 20. Possible, right? So I can keep. So this I can keep. So that's why 4 plus. So I'll write here 4 plus. What is 4 plus? What is the value of this box? Height of the box 2. 4 plus 2, which is 6. And now the value. Now the value already available is 2. So 6 comma 2. The maximum is 6. You will get here as 6. Now the next one. So j equals 0 is fine. J equals to 1. Now I'll take 6 4. Here you have 3 comma 1. Is that 3 less than 6? Yes, true. 1 less than 4? Yes, true. Anyway, area also true. So I can keep on box 1 also. So that's why you can see what is the value here on box 1? 5. 5 plus what is the value here? 2. 7. So 5 plus 2, which is 7, comma, what is the readily available value right now? Height 6. That is here 7 comma 6, that is 7 is the maximum. And when you keep 7, anyway we didn't update here previously 0. Now anyway box 1 you kept. So on box 1, that means 1 you have to write here. Now the next one, j equals to 2 you have to try. So 5 4 is there. Here 3 comma 1. Both are satisfying. 3 less than 5, 1 less than 4. Yes, I can keep. Now you can see what is the value here? 10. So 10 plus what is the value now? 2. So 10 plus 2, which is 12. Comma, what is the value available? 7. 12 comma 7. The answer is maximum is 12. So update it as 12. Yes, update here also the box 2. Now the next one, next j value is 3. So 3 is, now you can see here 3 is less than 3. No, you can see, of course, sorry, 1 is less than 2. Yes, fine, but 3 is not less than 3. Here area is satisfying, but length is not satisfying. That's why box 3 you can, box 4 you cannot keep on box 3. So it is not possible. So for that no need to update. So that's it for j equals to I equals to 4. Now the last value of I, that is 5. Anyway, j starts from 0. J starts from 0. You can see I is 5 here. J starts from 0. You can see 6 is, of course you can say 2 is less than 6. Yes, true. 1 is less than 5. True. And area also true. So I can keep. So the answer is 4 plus what is the value here? You have it is 3. So 4 plus 3, which is 7, comma readily available is 3. So 7 comma 3, the answer is 7. And update here as 7. Now here also you update it as 0. Now go to the next j value, which is 1. So what is the value here? 6 4. Here you have 2 1. 2 is less than 6. Yes. 1 is less than 4. Yes, true. So now what is the value you need to update here? 5 is there. 5 plus here 3. So 8 comma readily available is 7. 8 comma 7, which is 8 only. So update here as 8, and you are keeping box 1 here. Next I'll go with j equals to 2. So here you can see 5 4 is there. Here 2 1. 2 is less than 5. Yes, true. 1 is less than 4. Yes, true. Anyway, area is also 2 is less than 20. True. So now what you need to do for this box 2, right? What is the box 2 value here? 10 is there. 10 plus the available now is 13. That is 10 plus 3, 13 comma available is 8. Maximum is 13. So update here as 13. And here also you have to update it as 2. Now you take j value as 3. Now can I keep 3 5? So 2 is less than 3. Yes, true. 1 is less than 2. Yes, true. 2 is less than 6. Yes, true. So that's why I can keep. So values will be updated as here for 3. What is the value you are getting? Yeah, 11 you have. So 11 plus the value now 3. So 11 plus 3, 14, comma now available value is 13. So the maximum is 14. So I'll update here as 14, and here also update as 3. Now you check it out, 5 and 4. Can I keep box 5 on 4? You can say 2 is less than 3, yes, fine, but 1 is less than 1, definitely false. So that's why you cannot keep. So no need to update, and this one is also over. For 4 it is not satisfying, it is also over. That's it. Now this is a procedure where it is almost related to longest increasing subsequence. If you watch that video, I think you are surely able to understand this one, how we have done this height array. So this is what you have to do this, and now we have to find what is the maximum height you are getting. Now what you need to do after getting this separately, in height array you find what is the maximum value. Somewhere what is the maximum value you are getting anyway, here it is 14 will be your answer. Now 14 is the maximum height you can get from here. Anyway, I'll rub here. So now we'll find out. Anyway, we got the answer as 14. So how this is 14, which comes like among these 6 boxes. Okay, 3 here, 3, which has to kept on which, how we need to do. So we got the answer maximum height of 14 on h of 5, go to b of 5. So go to b of 5. What is the value here? You have to check it out. What is the value here? You have 3 is there. Go to 3. What is that? 3, 2, 1. So just write 3, 2, 1 here. Okay, so just write 3, 2, 1 here. Then go to 3. Where is the 3 index? You got 3, right? So go to 3 index. So what is the value inside you have? What is the value inside? 2 here. Go to 2. What is this? Okay, anyway, I'll write, okay, that is 5, 4, 6. So index 2, what are the values? 5, 4, 6. You can write here, and 2 is there, so go to 2 here in array, and what is the value here? 0. So I have to go for 0th box. 6, 5, 4. 6, 5, 4. Okay, yeah, go to 0. What is in this? 0. So anyway, we have 5th box, right? That we have not written. That is 2, 1, 3. So that also to be written. 5th box, so that also to be written. So now you can see this is the arrangement we can keep among 6 boxes. 4 boxes you can see, length, breadth, satisfying every time. Okay, including area. Now I told you height is 14. How this height is 14? 6 plus 4, 10 plus 1, 11 plus 3, 14. So you can verify whether you have done it correct or not, like this. So this is what we can try, whether you have done it. So whatever the answer you are getting, you have to check it out whether this is correct or not, like this. So like this we have to do. And anyway, what will be the complexity of this one? Let us suppose, so when I take an array, when I take a box, so where each box you might get 3, that means 3 into n elements you will get. Like if I have 4 boxes, 4 into 3, 12, like this you will get for each one. And first you need to take this one, then you have to store anyway big O of n complexity for this, and for arranging and taking the values, then especially for DP you have to go for n square complexity, right? So for the remaining you might get the complexity with the constant, like this. So finally the complexity you will get it as big O of n square for this one. So the complexity when you use with longest increasing subsequence, you will get it as big O of n square for this one. So like this we need to solve the problem of box stacking. So we'll see the next problem in the next video lecture. Thank you.